Master web development with Skill Bakery. Hey everyone, ready to level up your web dev skills? Introducing skillbakery.com premium courses starting at just $6 or 500 rupees. Sign up today and learn in-demand skill sets. Unlock your potential today at skillbakery.com.
Hello and welcome to another exciting video. In this one, we'll see how we can optimize web development with a Rust Webpack integration. Now, the approach of using Rust with Webpack via the Rust Webpack template offers several advantages over the previous methods of integrating Rust with WebAssembly using the Wasm engine. So here in this one, we'll be looking at the Rust Webpack integration, simplified build process with Rust Webpack, enhancing JavaScript interoperability, streamlining development workflow with Rust Webpack, leveraging Webpack integration for improved performance, exploring flexibility with JavaScript ecosystem, and debugging and hot reloading, which is made easier using the Rust Webpack. Then we'll do a SWOT analysis of the Rust Webpack template, starting with the first thing, that's the introduction to Rust Webpack. Now, it simplifies the integration of WebAssembly into JavaScript projects, enhances project performance through optimized bundling and caching, streamlines the workflow for Rust and JavaScript development, enables seamless inclusion of third-party JavaScript libraries, facilitates faster debugging with hot reloading and live reloading features. When we say simplified build process with Rust Webpack, it means that it provides us the automatic integration of WebAssembly into JavaScript projects. It also streamlines build processes with Webpack handling Rust and JavaScript, reduces manual steps for project bundling, enhances workflow efficiency with automatic WebAssembly and JavaScript file bundling. It also enhances JavaScript interoperability by simplifying interaction between Rust and JavaScript, by automating integration of WebAssembly output with JavaScript environment. It reduces complexity in managing JavaScript and WebAssembly exports, enhances code clarity by focusing on Rust WebAssembly logic. Streamlining development workflow with Rust Webpack allows us to automate the integration of WebAssembly into JavaScript project, speeds up development with live reloading and automatic rebuilding, simplifies project setup and enhances performance, provides seamless inclusion of third-party JavaScript libraries. We can leverage the Webpack integration for improved performance, and it allows us for efficient bundling of assets for optimized loading times, advanced code splitting capabilities for better resource management, caching mechanisms to enhance website performance, automatic optimization of WebAssembly output for improved project efficiency. We have to explore the flexibility within the JavaScript ecosystem. It allows us for incorporating third-party libraries, as I mentioned earlier, seamless integration with Webpack, and enhancing projects' flexibility. We can make use of the Rust Webpack templates capabilities within the JavaScript system. Debugging and hot reloading. So it allows us for hot reloading and live reloading for faster debugging. Updates in Rust code or JavaScript trigger automatic rebuilds and page reloads. Speeds up development and testing process with seamless reloading. Finally, if we have to do the SWOT analysis of the Rust Webpack template, the strengths are that it allows us for simplified build process with streamlined Webpack configuration, enhanced JavaScript interoperability through automated integration, faster development workflow with Webpack serve for automatic rebuilding, more integrated project setup with cohesive Rust JavaScript connections. As far as opportunities are there, potential for further enhancing Webpack integration for performance optimization, room for expanding flexibility within the JavaScript ecosystem. Now, the weakness is limited customization compared to manual configuration, dependency on Webpack for optimizing and bundling features. Threats are risk of dependency on the Rust Webpack template for future updates, vulnerability to changes in Webpack that may impact project setup. So now that we have covered all the aspects, let's go and look at the practical implementation of this. So here, we will be creating a new Rust Webpack project. What I've done already is I've created a directory, Rust Webpack project, and inside that directory right now over here in my PowerShell. And the first step over here will be to make use of the Rust Webpack. And for that, you have to have Node and npm installed. Make sure that's there. And then you can just go ahead and make use of the npm init Rust Webpack command. And this is going to create a default project for you, which will combine both the things, Rust, WebAssembly, and Webpack. So let's wait for a while till this gets created. Now, the next thing that we need to do is make sure that all the dependencies have been installed, and for that, we need to run this command npm install, press enter. And when you're making use of this Rust Webpack, you have to ensure that WebAssembly is already installed on your machine. We have already done that in our previous lecture, so yes, good to go over here. If the WebAssembly is not installed, you can just run cargo install WebAssembly as shown over here, but we have already done that, so we do not need to run it all over again. So finally, what we need to do is just make this command npm start and execute this. This is going to open up a localhost browser, as you can see over here, and behind the scenes you can see it is compiling, and this gets compiled. You'll have the title coming up over here, my Rust plus Webpack project, but it's not showing anything. If I give you the developer console over here, you'll see the hello world message coming up. So before going into the nitty-gritties of how this output is coming up, let's see what exactly this command has done. The first thing we have to look over here is the cargo.toml file. So in the cargo.toml file, if you notice this lib create type we were doing manually earlier, and these couple of different attributes have been introduced, like profile.release, features where we have the default vallop, and then dependencies, we were already taking care of it in our previous videos as well. And here for WebSys, it has provided this features console, so we are able to log into the console. And here we have the console error panic hook. It provides better debugging of panics by logging them with console error. So for that, we have the console error panic hook. And finally, we have dependencies. So these are some of the additional attributes that were included by default in our cargo.toml file when we are making use of the Rust Webpack template. And the next thing that I would like to open up over here is the webpack config.js file. So this is another file which takes care of the deployment. So over here, you can see the mode is set to production. The entry for this is the index.js file. The output directories are mentioned over here, the dev server and the plugins and WebPass and Webpack plugin. So here you can see all these things are basically included over here in the beginning of the file. Now, coming on to the src directory over here, you'll find the lib.rs file. And if I take you down below here, you can see the console log value that we were getting, hello world. So here, this is the method that gets called when the page is ready to be served. And what we can do over here is we can add a few more things just so that we can get an output over here in the page as well. For that, over here we'll be first of all introducing the WebAssembly engine. And remember, we had this extern C in our previous lecture. So that is what we will be doing over here, but we'll be introducing a couple of types over here so that we can create the body part right from Rust itself. So the first thing is we will be making use of the extern C command over here, and let's close this. And inside this, we'll be first of all introducing the HTML document. So here we have the HTML document, and then we will be using this HTML document to create or instantiate a type of a variable. So here we have the document type, and then we will be making use of the PyGen method attribute. And here we'll be introducing two methods. Create element, first of all, so that we can create an element of document type, returns an element over here. And then the other one will be just a getter. So here you will notice we have the method as well as the getter. So this is the body tag itself. And finally, we'll have the element type as well. So here we have the type elements. And again, we will have the set inner HTML and append child methods over here. So we have the bindgen method setter as inner HTML, and next thing we'll have the set inner HTML over here. Then we'll have the another bindgen, and this time we will have the append child. You'll notice why we are doing this when we'll be actually using this over here in our main method. So the first thing is we'll be creating, let's say, a paragraph tag. So for that, we are making use of the document.createElement. So you see over here, the create element that we created. So that is what is being used over here. Once the paragraph has been created, we'll be making use of the paragraph to set the inner HTML. And this is going to print something like this: hello from Rust, WebAssembly, and Webpack. So the set inner HTML is over here. And finally, the append child value that we have will be used over here. So here we have append child. We'll be making use of this now, and we'll set over here. Notice when I save this lib.rs file, how Webpack will compile everything and the output will be presented in our browser. So here I save this. You can see that it's compiling. And if you see over here, we are getting the output, hello from Rust, WebAssembly, and Webpack. Also, you'll notice the console message that was coming up is also presented over here in the console log. So that's how we make use of the Rust Webpack. If you find the video helpful, don't forget to like and subscribe.